Welcome to video section 7.2, day 1. This is calculating the area between two curves, and this can be a region anywhere on the XY axis. And instead of measuring from a curve to the x-axis, now we're going to look at measuring from the red curve to the blue curve. And both of these curves may have a function value. They may have an actual equation we can use. And what this slide says is that you're calculating the area between two curves. One is F, one is G. And you used a series of very small Riemann sums, which are little teeny rectangles. That's our whole premise behind finding the area under the curve and doing integration. And when we take the limit as delta x goes to 0, we actually get this yellow highlighted formula of sorts, where you take the one function minus the other function and go from a to b, which is your two limits of integration. And you always start with the function that is greater or higher on the x-axis. Tomorrow we'll do ones that go right to left, so with respect to y, and we'll do from right to left. But right now we do top to bottom, the function that's greater minus the function that's smaller. I just say top function minus bottom function. All right, so let's find this region, the area between 0 and pi over 4. I've listed pi over 4 as being way over here. So we are actually going to look at the area between the curves. Let's see, let's try a little highlighter here. This area right in here, that's what we're going to try to find. Not a straight line area, but my computer's trying to help me out. Okay, so yes, just that area in between the two curves. All right, so the way that we do that, we find which curve is on the top. Sometimes this is a little challenging, by the way. So your area equals the antiderivative of secant squared minus sine of x, because sine is on the bottom, dx. We're going from 0 to pi over 4. And then you get to evaluate this. Area is tangent of x, if you take the antiderivative of these, plus cosine of x, and evaluate this from 0 to pi over 4. And the area you get is square root of 2 over 2. Take the function with pi over 4 minus the function at 0, you get square root of 2 over 2, or 0.707. I like the square root of 2 over 2 better. Okay, that's how you do it. Top function minus the bottom function. Okay, so here again we have an area enclosed by the parabola and the line. Often these are given like this, and you have to figure out what your limits of integration are, where these two intersect. All right, so we know that the parabola is on top, so 2 minus x squared minus negative x. And let's put those babies in a big bracket and write a dx over here. And then let's figure out our limits of integration. This looks like it's negative 3. And what you can do to find the limits of integration is set these two y's equal to each other to figure out what the x is. And you'll actually come up with 2. I'm sorry, this is actually negative 1 to 2. Now, the way we came up with those is setting these two equal. So 2 minus x squared equals negative x. If you're on the calculator part of the AP test, I'm going to subtract 2 and move these to the right side. If you're on the calculator part, you can look on your calculator and see where they intersect. But if you're not, you're going to have to figure this out on your own. So you should know how to do this. Set the two y's equal to each other. And then we're going to factor, we're going to get x, x minus 2 and x plus 1. Which gives us our 2 points of intersection, x equals -1 and 2, which become our 2 limits of integration. Okay, so that is where those came from, which is important to know. And if you do the antiderivatives of these, you get 2x minus a third x cubed minus a minus, which is plus 1/2 x squared. Evaluate that from -1 to 2, and you should get the area is 4.5. All right, so that's the area in between these two curves, which means from the parabola down to the line. All right, next find the area in the first quadrant bounded by square root of x and the line x minus 2. Okay, let's draw those. Okay, I've drawn these two functions. The blue one is y equals square root of x. The red one is y equals x minus 2. All right, well, one thing we have to do here is, we don't want, between 0 and 2, remember we're only in the first quadrant, we only want the area, and we want this little wedge of an area right here, but we only want the area down to the x-axis, because we don't want anything lower than the x-axis. We want it all in the first quadrant. So taking the integral between these two curves in the first quadrant from 0 to 2 is just a matter of doing 0 to 2. And let me show you how I got, I found that this is where the y equals x minus 2 line intersects the x-axis. When x is 2, y is 0. So you have to figure out where y is 0. And then we'll talk about the other one in just a second. Okay, so from 0 to 2, we're just going to use square root of x dx. And we have the area between 0 and 2. Now, we're left with the other area we need to figure out. And we know that we're going to take square root of x function and subtract x minus 2, correct? Correct. Because the square root of x is the top curve and the line is the bottom curve. So we're going to add that. We need to know what our limits of integration are. We know the bottom limit is 2, but we're going to have to do a little calculation to find the second limit. So square root of x equals x minus 2 if we set the two y's together, right? And we want to find x's. So we're going to have to square both of these. Aha! This becomes x. And we actually have to FOIL x minus 2 times x minus 2. We're going to subtract x from both sides, so we'll have x squared minus 5x plus 4 equals 0. If we factor these two, we get x minus 4, x minus 1, right? So our two places where these lines intersect are 1 and 4. All right, and we are, they don't actually intersect at 1, I don't know why that comes up. But anyway, we're going to x equals 4. So, because that's where the two meet on the right-hand side. So our limit of integration then is going to be 4. And now we can figure out the area between the two curves using these two antiderivatives. And remind me to show you the Calculus Rhapsody. I have lots of cool videos on here. Anyway, so if you add these two together, do the antiderivatives, add them together, which I'll leave you to do on your own, you get 10/3 minus 4 times the square root of 2 over 3. Oh, I know, I see. Actually, let me rewrite that. This is over here, and this one is 4 square root of 2 over 3. So if you add those together, you're just going to get 10/3. All right, so that is, this is the antiderivative of the first one, this is the antiderivative of the second one. Okay, so you end up with 10/3. All right, you can check my math on that. That's the end of our little information gathering session today. See you next time on 7.12, day 2. We're almost done with the book.